has to be a better way. Oh. All right, Adam with no book. No nothing. Okay, so this is the last thing we looked at, right? Talked about outlier where, you know, if you're talking the average salary of like teachers, you don't throw in a doctor's in there because we don't make that kind of money. So that's where we kind of ended there. And then the next one was finding the mean of a frequency distribution. So remember, a frequency distribution, that was after you made all like your tallies. You had your class width, and then you had your tallies, then you had your number, and then, okay, so finding the mean of that. So this was just kind of the directions of finding this. So the first thing they said do is find the midpoint of each class. So remember, you broke it down into the classes. So then it says find the sum. That's what that sigma x there is. You take your midpoint times the frequency, how often it happens. So if that one happened 3 times, take it times 3. And then you add all those up. And then your frequencies is like if it happened, you know, all of them was like you had 30 tallies. You divide by 30. So it's finding the mean of that. So how often it happened. So like when you did your tallies. Here, I'll take you to the book. Oh, Adam's not gonna be able to see that. We don't really care because he left us. So if you went through the frequency distribution at the left shows the out-of-pocket prescription medical expenses for 30 adults. So remember, there were just 3 people, like on your histogram, like that went 3 high, then it went 2 high, and then it went 5 high and 6 because there was like 5 people that were in that class. So when you're dividing by, it's the total number. It's a total number of tally marks you have. So if it happens to be in a survey, you ask 30 people, you already know what N is. You just don't have these things broken down of like, oh, 3 people landed in this range. 2 people landed in this range. But from the beginning, you should know, because it says in here, medical expenses for 30 US adults. You just have to make sure that column right there adds up to 30. Otherwise, you can't count tallies. Okay, so all they did was, when I said they found the midpoint, took it times the frequency, and then they added those up. There's your sum. And then when you divide that by the 30, that is your mean of that kind of group of data. Otherwise, it's like you go in there and you'd have to add that one, that one, that one, that one, that one. You'd have to add up like 30 different numbers on there. So you don't want to go through all of that. Okay, so that's where we left in the notes. And Adam doesn't have his book. Okay, so that's where I kind of left there on that. I don't know why I didn't finish that out, but that was on there. Okay, so then I gave you a little video there just talking a little bit about variance and standard deviation. I would say the one they said they use variance and standard deviation. I mean, variance would have its own place. Most of the time we talk about a standard deviation. When we do standard deviation, it's kind of a little process. So when you guys have to do it by hand, it'll be a small set of numbers. Because if your numbers get big, you don't want to do that. And then we'll do it on a calculator also. Okay, so, but on here, they'd like you to do it on that. By hand, just see that. Okay, so measures of variation. The range, we've already really talked about taking your maximum minus your minimum. That just gives you the range of values. It doesn't tell you a lot. It doesn't tell you, you know, if you have outliers in there or something. It's just, that's the difference between the highest and the lowest. So it doesn't tell you, it tells you kind of the spread of the data a little bit, but if, like I said, if there's an outlier in there, it's not good. So the deviation, this is kind of where you get into that kind of bell-shaped curve. In the middle, you got kind of your mean. And then deviation is how far it is away from the mean. So kind of most of your data should be within one standard deviation of the mean. There's certain percentages, and I can't think of what they are right now. But that's what that is. I kind of put in, they use a lot of Greek letters. You've already seen sigma. I think that's mu, where it looks like a U with a long front U thing. So just kind of get used to, and actually in here I gave you what those were. So you got to find the variance first, and then when you square root that, that will give you the standard deviation. This video is the video you watched about Harry Potter. Was it Harry Potter? Yeah. Okay. Okay. So this is where I'm saying statistics not so bad, but then your formulas get kind of ugly. And this is small. This is small compared to. We have.
You said we get a sheet though. With the formula.
Yeah, I'm gonna give you a sheet.
Okay.
Because some of these, it's off the charts there.
Yeah.
So with this one, and I think I put on the next slide, which Adam doesn't have right now, is kind of what everything means there. So in this one, the first one is your variance, and then how do you find the standard deviation is you just square root that number. Okay, so the sigma means sum. X is your data point. So the data I give you, that's one of those. That X with a little line over it, that's the mean.
Okay.
Okay, so, and I think on the next slide,
So
what you
X
have.
is just random.
X is just like if I give you a list of data, it's one of those.
Okay. I'm gonna get like
Here's the tree. Okay, and then what you're gonna do is you're gonna take every point that I give you, and you're gonna subtract the mean. And then you're gonna square that number. So that's what that top line,
Problem like 7 times.
kind of.
Okay.
And then it's always, they say on this one, it's always divide by n minus 1. N is the number of entries you have in your data.
Okay.
On a sample, they do this. So I put in here what they're talking about. So they'll talk about, maybe I can go here. I'm going to go here first. So when they're talking a difference between a population and a sample, this is kind of the difference between those two things, because on a population standard deviation, you just divide by n, but on a sample, you do n minus 1. So the population is everything, and then a sample of it is just a sample of, like a subset of that. I put that kind of difference in there. I think most of the time, I want to say most of the time, we'll deal with a sample set here. And again, if you find it the same way, but the only thing you change about it is you either divide by n or n minus 1. I don't know why they had to go in and change all the things. Unless you're just looking at that mu where it says mean. Okay, that's just the mean of the population, where the X with the hat over the, I'm not sure why that all has to be different. Because it's the same thing, except your population's gonna be huge, but it would still be the same thing. Okay, so like I said, in a computation is the same when you're doing everything, except for in a population, you divide by the number and not n minus 1. Okay, now we're going to top of page 86, which, is it 86? It's 86. Okay, so I'll kind of write the numbers here. We're just gonna go through finding. Did you grab a calculator? Okay, maybe grab top page 86. Why can't I know my numbers here? Okay, so Adam, who is not here, top of page 86 is you have We're gonna find the standard deviation, variance and standard deviation of these numbers. Okay, so it said refer to the, here. So if Adam at home wants to write down those numbers. Okay, so refer to the study in example 3, the recovery times and days for group 2 are listed below. So that's what these are of this group. So with standard deviation is go through and find the mean. So how did we find the mean? Add up all the numbers, divide by how many numbers you have, and you have 8.
$39.5.
39.5. Okay.